students. So in the last class we saw some introduction regarding Travers surveying, right? So in the what is first of all what is mean by Travers, right? So Travers means we are going to move on, right? So we are going to move on, okay? So that is called traversing, passing across, okay? So here we are going to take the length, right? Horizontal length as well as the directions, right? So length and directions. If you are going to start from one point, okay, moving in a continuously, okay, this is called Travers, right? Here we are going to determine the length and we are going to determine the direction, okay? So length will be measured as a horizontal distance and direction is going to measured as the angle, right? So here the linear measurements are going to take with help of chain or tape, and we are going to take directions along by using the compass and as well as the theodolite or any given chain also we are going to use, okay? So now, this is type of survey in which the number of connected survey lines from the form the framework, right? So these are going to form the framework, okay? So and that framework is going to have the directions and length, okay? So direction is going to measure with help of the angle, in terms of angle, and with the compass or any other equipment like theodolite, and linear distances are going to measure with help of the tape or chain, right? So normally these Travers will be two types. One is open and another one is closed one, right? So first of all, what is called closed one? Okay, closed Travers means, right? So wherever we are going to form a circuit, right? So if you started from one point, you are moving on, and come to the last wherever you started now. So this type of traversing is called closed Travers. Not if you are moving, okay, continuously, and you started here and you ended at some other point, okay, it is like a open, no? So that is called open traversing, okay? So that's why you know two types of traversing: open traversing and closed traversing, right? So open traversing is like this, okay? So closed traverse will be like this, right? So it is going to be closed one, okay? Next of all, next topic in this class we are going to see, that is methods of traversing in surveying, right? So here the linear measurements can be performed by the methods which are listed in the horizontal method, right? So in the horizontal method now we are going to use chain or tape methods, okay? So now survey chaining, perhaps the most common. Normally we will use chain surveying, and the directions are going to measure with help of a compass surveying and a theodolite, okay? Anything can be used, okay? So but here for the precision, if you want to get accurate values, we are going to use the steel tape, okay? Inverse steel tape for the horizontal measurement and theodolite for the horizontal, what is called directions measurement, that is angle measurement, okay? So however, any other combination of linear and angular measuring equipment may be also used, okay? Now there are several methods of traversing depending upon the instrument used in the determining the relative directions of the traversing lines, right? So whatever the equipment you are going to use for the measurement of horizontal distance as well as the direction, okay, based on those things the methods of traversing is going to what is called depends, right? So that's what we study. There are several methods for traversing, okay, depending on the instrument used in the determining the relative directions. We are going to determine the relative directions of the traverse lines. The following are the principal methods, okay? These are the four principal methods we are having in the traversing methods, okay? The first method is chain traversing, okay? The name itself is telling that we are going to use the chain in that one, okay? Next we are going to use the chain and compass, okay? In the first method you have to observe one thing, even the angle also you are going to measure with help of the chain. So how we are going to do, we will see now, right? So chain traversing, then chain and compass traversing, that means chain will be used for measuring of distances and the compass is going to use it for the measurement of angles, okay? Next, transit type traversing, okay? Transit means, so we know front and back, okay? Here we are going to use the fast needle method, okay, and by measurements of angles between the lines, okay. So you are going to use compass or theodolite here, and finally we are having a thing called plane table traversing. So we will see one by one. The first thing is chain traversing, okay. The method in which the whole work is done with chain and tape is called chain traversing. So already told that. So here the whole traversing is going to done with help of the chain only, right? So this is the method in which the whole work is done with the chain and tape is called chain traversing. If you are doing traversing with help of a chain or tape, that traversing is called chain traversing, okay. Now no angle measurement is used, and the directions of the lines are fixed entirely by the linear measurements, right? Angles fixed by the linear or tie measurements are known as the chain angles, okay. So here for angle measurement we don't have any special type of equipment here, okay. So here what he is going to do now, there is no angle measurement here, but the directions of the lines are fixed entirely linear measurements, okay. So the angles fixed by the linear or tie measurements, okay. Okay, up to here, full stop. There are entirely linear measurements, right? So normally the angle will be fixed, right? So how much angle you have to do now? So that direction is going to fix, okay? So with that only we are going to move, right? Now angles fixed by the linear or tie measurements. If you are fixing the angle with the linear measurements, those are called as the chain angles. The method is unsuitable for accurate work, okay, since we won't get exactly angle, no, we don't get any exactly angular direction, so that's why this method cannot give us the exact values, okay. So you won't get that's why it is unsuitable for accurate work, right? So and is generally used for angle measuring instruments such as a compass, sextant, theodolite is available, right? So if, when accurate measurement will come now, so whenever you are using any type compass or any theodolite for the angle measurement, then only you will get here, okay. So what is chain surveying? Here the traversing is done by only chain or tape, right? We are not going to use any angle measurement instrument. The angles are going to be a fixed one, and those angles are called chain angles, right? So this is not accurate method, right? So next move on to the second method, that is chain and compass traversing, right? The chain, okay, in chain and compass traversing, the magnetic bearings of the survey lines are measured by a compass, right? So what is magnetic meridian? If you are taking with respect to north direction, right, any angle, okay, so that if this line is this is theta 1, if line is here, theta 2, if line is here, theta 3, right, so like this, okay. So if I am taking one point A here, if I am going to move to another point, okay, so now again like this, okay, these type of bearings will be taken with help of the compass, and the linear measurements or lengths of lines are measured with the either chain or a tape, okay. We are going to use either chain or tape to measure these distances, right, and the angles are measured. That's angles are called bearings. Whenever you are measuring the angle with respect to the north direction, so that is called bearing, okay. So the direction of the magnetic meridian is established at each traverse station independently, right? So here the direction of magnetic meridian is established at each traverse station. If you are putting here the with help of compass, okay, so we are going to establish the magnetic meridian. That means every case, okay, here also we establish the magnetic meridian, here also, everywhere we are going to establish the magnetic that is meridian, right? So that method is also known as the free or loose needle method, okay. So this method also is known as the free or loose needle method, okay. So next move on to the third one, right? Okay, so next third method, that is traversing by fast needle method. Okay, so the method in which the magnetic bearings of traverse lines are measured by a theodolite fitted with a compass, right? So is called traversing by fast needle method, right? So here we are going to fix, right? We are going to fix the compass. We are going to fix this compass to a theodolite. Okay, we are going to fix the compass to a theodolite, right? So at every station you are going to measure the what is called angles, right? With help of the theodolite you are measuring angle, and with respect to the compass, right? So those are called bearings, right? In which the magnetic bearings of traverse lines are measured with a theodolite. Angle is going to measure with a theodolite. Why? Because compass we don't have the readings in terms of seconds and in terms of minutes. We won't get the exact value by using the compass. Only we are going to get the exact reading by using the what? Theodolite, right? So theodolite is going to give us very exact accurate value. That's why in combination of compass with the theodolite is going to get the in terms of north direction we are going to get the magnetic bearings. Okay, so that's why this is called fast needle method, right? So the direction of magnetic needle is not established at each station, but instead the magnetic bearings of lines are measured with a reference, so that the direction of the magnetic meridian established at the first station, right? So once ever you are establishing the magnetic direction at the first station, so you are not going to establish at each and every station. With respect to first we will fix here, then we will no need to measure. Okay, by using this compass as well as theodolite we will do that. Okay, so there are three methods of observing the bearings of lines by fast needle method. By using this method there are three methods. One is direct method with transiting, direct method without transiting, okay, back bearing method. Okay, so transit means in the horizontal direction, if you are moving front and back now, so that is called transiting. Okay, see the first thing, traversing by direct observation of angles. Okay, traversing by direct observation. Okay, so in this method, angles between lines directly measured with a theodolite and the magnetic bearing of other lines can be calculated in this method. The angles are measured at different station, maybe included angle or deflection angle. Okay, so what is the included angle? This one. If you are having like this is the included angle. Again from here, if your line is moving like this is another included angle, right? So these are called included angles. If you are having deflection angles, this how much it is get deflected, those are called as the deflection angles. So in this method, angle between the lines are directly measured by a theodolite and the magnetic bearing of other lines can be calculated in this method. Okay, so if you are setting the theodolite here, you can know the angle between this line and this line. Okay, so that's what he is telling. Okay, the angle between these two lines are directly measured with the help of a theodolite and the magnetic bearing of other lines can be calculated in this method, right? So you are going to calculate the magnetic bearing of other lines. Okay, so next, traversing by the included angles, right? So an included angle at a station is either of two angles formed, right? Two angles formed are okay. So by two survey lines meeting there, and these angles should be measured clockwise, right? So if two lines are what is called meeting at same point, so here the angle, whatever angle is going to form, that is called theta, right? So these angles are going to calculate with the help of the what is called clockwise direction. Okay, the method consists of simply in measuring each angle directly from a backside on the preceding station. The angle may be also be used for repetition. Okay, so again, if you are measuring like this first angle, after going this you are going to calculate the back bearing. Again, fore bearing you are going to take. Okay, so whatever angle is there, right? Okay, so whatever angle is there, this is the front direction, this is the back bearing, and this is forward bearing. So we can calculate the included angle, right? So the angles measured from a back station may be interior or exterior depending upon the direction of the progress, right? So here we have two figures. The figure A, the direction of progress is counterclockwise, and so that the angle may be are the interior angles, right? So if you are taking at each station now, so if you are measuring values now like this, okay, so if you are not doing calculations, right, these are exterior angles, we are going to get, so how can you say, okay, so here if you are taking like this, the angle between these, okay, this is called, okay, outer clockwise, okay, so angle measured clockwise are interior, right? So if we are moving in a clockwise, those are angles called the exterior angles, right? So if we are measuring like this, right? So first point I was telling, the direction of progress is counterclockwise direction, so that the angles measured clockwise are the interior angles, okay? So if you are moving like this, this is the first point, right? So here whatever we are doing, we are moving, we are measuring the angles in a clockwise direction. This is the clockwise direction. Then, so like this, clockwise direction, you are going to measure the angles, okay? So that's why these are called as the interior angles. So interior angles, how we are going to get? So you are going to get like this, okay? This is the interior angle, okay? So like this you are going to get interior. If the direction of clockwise, if you are moving your Travers in a clockwise direction from here, okay? So the angles measured are clockwise, okay? So those are the exterior angles, okay? Outside, okay? Around the exterior. Then Travers by deflection angles, okay? So a deflection angle is the angle in which a survey line makes with the prolongation of preceding line, right? If you are, okay, so if you are making like this now, prolongation of the preceding line, okay? So wherever the angle with the survey line makes with, okay, so one go to chase angle ni deflection angle antaru. Ee station nunchi next second anta deflect ayindi, right? So it is designated with as a right or left as it is measured clockwise or anti-clockwise. So if you are measuring this in a clockwise direction, that will be a right one, right? So or you can terminate as till as it is a left. That's why it is called a anti-clockwise from the prolongation of the previous line. Okay, this type of traversing is more suitable for the survey of roads, railways, pipelines, and where the survey lines make small deflection angles. Very small angle deflection angles. Okay, so next we are going to talk about the errors in the traversing, right? So if you are taking readings like measurements, horizontal measurements, and that means linear measurements with the tape or chain, or if you are taking the directions with help of the theodolite or compass, okay? So we may get some error values. How we are going to correct it, right? So the errors involved in closed traversing are two kinds. We will see how errors will come in open traversing and closed traversing. Okay, so here in the closed traversing, first of all we are going to discuss. In the closed traversing, we are going to get linear error, and the second one is the angular error, right? So linear error and angular error. What is linear error? In the linear direction, you are getting any error, that is called linear. If you are getting any error in the case of angles, that is called angular error, right? So the most satisfactory method of checking the linear method measurements consisting in chaining each survey is a second time, preferably in the reverse direction on the different date and by different parties. Okay, so the following checks are the for angular work, right? So first of all, what is telling now? So if you are taking the linear errors, no. So linear errors, what you have to do, once you have measured the length, no, again you have to measure it again. Okay, there is no check. If you take any tape or chain again, so with different persons, right? So if it's different party, you ask them to measure it again. Okay, so then only we can say, we can find out whether there is a error in the linear measurement. Okay, so the angle are what is called checked with help of these things. Okay, so traverses by included angles. Okay, traverses by deflection angles, and traverses by direct observation of bearings. Okay, so these three cases will be there. Okay, so if you are calculating the included angles, the sum of measured included angles should be equals to 2n minus 4. The sum of all included angles, whatever you calculated now interior angles, so those all become to 2n minus 4, right? So where n is the number of sides of the traverse. Okay, so the number of sides of the traverse. If the exterior angles are measured, their sum should be equals to 2n minus 4 into value 2 in q. Okay, so whatever angle is there. Okay, so 2n minus 4 into 90. Okay, so this value total value equals to be equal. Okay, now second thing, traverses are by the deflection angles. Okay, so the algebraic sum of the deflection angle should be equals to 360, taking the right hand side, and the reflection angles are positive, right? On the left hand side they are negative, right? So if we are moving right side, those are taking as positive. If angle is there on the right side, it will be taken as negative. But all values, if you are making algebraic sum, it will become 360. Okay. Next, traversing by direct observations of bearings. The fore bearing of the last line should be equal to its back bearing of the back bearing plus or minus 180. Right. So if it is more than 180, you are going to deduct 180 from that value. If less than that 180, now you are going to add 180. Okay. Therefore that. Okay. So the fore bearing of the last line should be equals to back bearing of the measured from the initial station, right? So if you are having this like no, so you started somewhere else. Okay. So this from here, if you are taking back bearing, this is fore bearing, right? So the difference between these two, it will be 180 degrees. Okay. So next, checks in the open traverse. Okay. So how we are going to check the open traverse? So now we should see the closed traverse, right? So no direct checks for angular measurement are available. So indirect checks can be made, right? So here we have something is called, right? So some figure they give. So the addition to observation of bearing AB, right? So from AB, okay. So addition to observation of the bearing AB at a station A, okay. So bearing AD can also be measured, right? So from here, okay. So instead of measuring this bearing, no, you can measure the bearing towards the AD, okay, if possible. Similarly, at D, the bearing of DA can be measured and check applied if the two bearings differ by 180. Okay. So ఇక్కడ ఏం చేస్తాం అంటే B తో ఒక రీడింగ్ తీస్తాము, then D కూడా ఒక రీడింగ్ తీస్తాము. Whenever you reach to the D station, if you are taking angle like this, no, okay, so the difference between these two angles should be with a difference of 180. Okay. So if that enter, that is accepted. Okay. So another method ఏం చెప్పారు చూడండి. Here the check when work is partly showing in the figure and consists of reading the bearings at any prominent point P, right? So from each of the consecutive station, the checking plotting consists of laying of lines AB, BP and noting whether the lines are passing at one point, right? So if you are taking one point here P, right, on the same point will be there. From here we are going, this is actually traverse. This is actually the traverse. Okay, we are going to see from this point. We are going to check whether these are moving rightly or wrong. Right. Next, we have the Triox computation. right? So in this figure, right? So this is the x direction, y. This is minus x. This is minus y, right? So in here, the latitude and the departure of line AB. Suppose this is line AB. This is line AB. Okay. So if you are measuring the distance, right? So this is the length L, right? This is the theta. Sorry, where he took it, there he took the Q. Okay, sine Q, right? So if you are measuring the length, right? So here, what is cos theta? This side will be cos. Sorry, sine, and this will be the cos. Okay, so this horizontal length L. L is equals to how much? Plus L into cos Q and departure. Okay, from here, this length, right? So that is plus L into sine Q. Okay, like that we are going to do, right? So to calculate the latitude and departure of the Travers lines, it is first essential to reduce the bearings in the quadrant system, right? So here, it is a one type of angle calculation, right? So if you want to find theta value and you want to check the accuracy of traversing, you need to do these computations, right? So in the next topic, omitted measurements also, we are going to deal with this thing. This is the fundamental topic for that topic, omitted measurements, right? So now to calculate the latitude and departure of the Travers lines, okay? So we are going to reduce the whole circle bearing system into the quadrant system, right? So the signs and latitude departures will depend upon the reduced bearing of the line. The following table given are the signs, right? So here we have a point O, okay? From O we have OA, OB, OC and OD. See the first thing, OA. OA is in the first quadrant. Now both x and y will be the positive. Here x will be positive, second quadrant, okay? Sorry, fourth quadrant, this one. Minus, okay? This is plus, this is minus. So here x value will be minus, y value will be plus. Here 2 will be minus, here plus minus, okay? So these are the things now. So first we can say this is the north direction, that's why OA is equals to north, east, okay? So that's why these two, this is at south, from south now, southeast is OB and southwest is the OC, that's why OD is also from north west, okay? Like this. Quadrants is, first quadrant is this, okay? We know this is fourth quadrant, this is third quadrant and this is the second quadrant, right? So latitude and departures, okay? So every time value will be same, but we need to take care about these signs, in which quadrant it is there. So what will be the latitude and line departure, right? So here you can see in the fourth quadrant, since latitude from x-axis, no, so that's why it is, sorry, from x-axis, right? So from x-axis, no, L cos theta, so that's why it is negative direction. If you are moving like this, it is a positive, that's why L2 sin theta B is there, right? So like this, thus latitude and departures coordinates of any point with respect to preceding line are equals to the latitude and departure of the line joining the preceding line, right? So ముందుకెళ్ళే లైన్ వెనక వచ్చిన లైన్ యొక్క రెండు ఏమంటారు latitude departures same ఉండాలి, right? So under any circumstances, such coordinates are also known as the consecutive coordinates or dependent coordinates, okay? So this is all about Travers surveying, right? So if you are taking this what is called latitude and departure, right? So for that you may find some errors in the this closed Travers or open Travers, right? So how to find out the those missing measurements or how to check the accuracy, those are going to discuss in the omitted measurements. Next topic in the last topic in the third unit, that is omitted measurements, okay? So until now we discussed about what is meant by Travers surveying, what are the different methods, okay, types, so that is closed Travers and open Travers, and we saw the different methods with help of the chain, with help of the compass and chain, with help of the theodolite, with help of the plane table, right? So those are the things. Already plane table traversing we already discussed in the case of plane table surveying, right? So next topic we are going to discuss about the omitted measurements, okay? So that's all for today. We'll again discuss about the omitted measurements in the next class. Okay, thank you.